And good afternoon, good evening, wherever you are in the world. You have reached Saturday Science Chats. Yes, you've reached Saturday Science Chats, sponsored by the John Chappell Natural Philosophy Society and Dissident Science. I want to thank everybody for tuning in. Of course, what do we have today? You don't want to miss it. This is going to be the best in the series. This is our series on evolving perspectives on the history of science. That is, people who work outside the mainstream. In fact, are people who have a very different view of history. When we see things, we see the same things, we see the same data, we see the same scientists, but we see them in a different way because we do not accept everything we're told. We actually investigate it. Can you believe that? Actually think about what you're reading and question it and decide for yourself whether you believe something is right or wrong. And of course, this is great because he says he has a surprise ending. I do know the word banana is in it. So, anyways, I want to congratulate you for watching because, as Aristotle, whoever said it, I say whoever now because people have told me that maybe it wasn't Aristotle said it. It doesn't matter. What is said is most important. That is, it is the mark of an educated mind to be able to entertain a thought without accepting it. What does that mean in layman's terms? It means, hey, when somebody has a new idea, be open-minded. Think about what they're trying to say. Even if it sounds like you're going to totally disagree with them, give it a chance because you never know. That could be the next paradigm. You never know. But I do want to congratulate everybody for watching. I want to thank my Dissident Science channel subscribers. Thank you so much. My goodness, it started zooming up. I don't know why. We're like 4,100 and I don't know, 4,130 subscribers or more. And also we're at 991 so on the John Chappell National Philosophy Society. If you happen to be watching that, just click on the little subscribe button and the little bell and you'll be notified when we're on live, just for support, folks, because once we get to 1,000, that John Chappell can accept super chats and those donations from you, because this whole thing costs us a couple $1,000s to keep running all year round. It's really worth it because it's the only place on planet Earth that does these kinds of shows, sessions, talk with these people. So, but I do want to thank you because you are certainly a critical thinker if you're sitting and watching this. And of course, I go too fast because these controls are terrible. Anyways, just remember we are all in this together. Let's fight illogical mainstream science, not ourselves. Just don't, if you have a disagreement, disagree, but just don't get nasty with people. It's just not worth it. It doesn't do any good. It's no fun. Let's argue about the real issues and get into it because as my dad says here, no one, we are all wrong. Some ideas are less wrong than others. And so you don't want to fall in love with your ideas. It's a really dangerous thing. And speaking of which, sorry about that, folks, flipping through it. We're wishing my dad well. He is currently in the hospital. It's got some problems with his heart, but you can see here, he said, bring my laptop. He's working on his book, literally there, working on some circuits. We've got an experiment we're doing with, believe it or not, just electricity and magnets. And it's doing stuff that people don't know why or can predict, and we're going to try to look at that. Also, he's working on another experiment, which is a resistor and an inductor. And also is looking at experiment that with about that, and of course his explanations that he uses, which is the particle model. And of course our CNPS mission is to be an organization that promotes critical thinking without malice. Our organization supports, publishes, and promotes the scientific word outside the mainstream to provide forum for open debate and modern topics in physics, cosmology, philosophy, mathematics, all of those things, and to provide a forum for presenting a serious papers and theories without fear of censorship. And we are run and controlled by everyone here. In fact, we again are supported by everybody here. Click the like button, click the subscribe button, and of course you can go and visit our websites. Beyondmainstream.org, I think, actually hit 100,000 views. I'm going to go check that right now. Beyondmainstream.org, and there's a page that tells how many views we've had so far. And yes, indeedy. We passed 100,000 back on on actually February 28th, almost a month ago. So I want to thank everybody. We're averaging probably about 100 a day reads of that for a non-mainstream magazine. That's pretty cool. But if you haven't checked it out, you should. Really great articles there, videos, a lot of explanations. A great scientist, all the scientists working outside the mainstream who are really going to be the next mainstream scientists, and then we'll create dogmas around our people. Inside joke, I guess. If you want to join our critical thinking community, which is quite active these days, which is great to see, just go to naturalphilosophy.org. Natural philosophy, of course, is the word that we used before we called something physics. I think natural philosophy is a way better name for it, and that's why we've gone back to it. And so you can go in there, sign yourself up, and get into the discussions about all kinds of things: ether, time, expansion tectonics, the Big Bang, all kinds of things, the speed of light, all those things. So great community. Get in there. And we also have a Wikipedia. It's wiki.naturalphilosophy.org. It's a natural philosophy Wikipedia. Of course, we can't put in alternative ideas because Wikipedia's idea is to be the consensus of consensuses of consensus. So if you don't aren't conceding or not consensus, that's the same word, I don't know, but if you're not agreeing with consensus in science, not likely you'll be published there. So check those all out. And of course, we are sponsored by memberships and donations. You can do monthly donations as little as $5, $10, $25, $50. We have people at all those levels, and we also have annual memberships. So if you're on a tight budget but want to help out, it's really important. Without this, we don't go. And we're always on the brink. So I'd like to get us a little bit above the we need another donation from somebody to keep going. Again, it costs about $2,300 to keep this going. All subscription stuff. Subscriptions for a server for every year, it's about $1,000. Again, that's for the whole year. Per month it's less than 100. Then we have our subscription software that we use, which makes the ability to have the community. We even have a subscription software to be able to collect your monthly and annual fees automatically. It just goes on and on and on. Keep our server from being hacked, because we were hacked for 5 years because people don't like us talking against the mainstream. And of course, you can also make donations. Here are some of the patrons. We want to thank Nick Percival, who's going to be speaking today, Dr. Cynthia Whitney, Ramsey, and all our annual monthly memberships. We need your vital support. Big emphasis on vital, meaning our life is in your hands. So please, 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 if you can, go to naturalphilosophy.org. And in fact, I'll put that banner up running at the bottom so you guys know where you can go. So there we go. It's running there. That's where you can go to sign up or even just give a donation. And everything and anything is welcome. So please help. Coming soon, well, my dad, hopefully, when he's out of the hospital, he's going to be talking about the physicality of parallel resistors, diodes, and transistors. Believe it or not, we know almost zero about electronic components and the real way they function. We talk about electrons, but somehow they don't even go meters a second, or they go meters a second, and yet we all know the electricity goes way faster than that. So current is actually the holes left behind that move backwards. It's absurd. We have lots of electrical engineering is the most successful, in my opinion, of engineering, other than mechanical engineering and Newton. And of course, we do not know how this stuff really works. My dad's an electrical engineer. He's going to be talking about that. We're going to have the great debate coming up. I'm not an etherist. I don't like the model of ether, but a lot of people do. And we're here to respect all sides. And we're going to talk about ether, pros and cons, because believe it or not, we do have people in our organization that don't believe ether is a good model. And that's okay. And I will tell you again, I am not here to tell if you're an etherist, you're not smart, or that's the wrong model. That's my opinion. Ether could be correct. Yes, it could. I don't think so. I think, again, with problems, but it could be correct, and I could be completely wrong. And if you have that attitude, that's what you should. I'd like to find an etherist say that to me and really mean it. I've heard people say it, but I don't think they really mean it. I think people need to know that it's not the only thing out there, but it's going to be a lot of fun. So you want to come up and get into I'm going to put out some stuff that I want answers to that if you're an etherist, you know, and people always say, tell me what it is so I can tell you why it's right. And I go, okay, we'll have it. Anyways, we do have a great debate coming up, and I'm going to get some people who are going to take the side. And we'll basically, and also the other thing was I'm going to do, I just started this morning, this week, the idea, but we are going to do this. We're going to have Lifetime Achievement Awards. Now, we have given those normally out once a year at our in-person conference, but because we're doing this every week, it's like, wow, it's almost having a conference all the time. So I am planning, because there are some people we missed that have passed on that I really regret not giving them the Lifetime Achievement Award. Again, these aren't things that are going to necessarily, these people are going to go down in history for what they're doing, but they are certainly people who work outside of the mainstream, or critical thinkers who have come up with different models, with different ideas, and worked decades on those, and those people should be recognized, and we should encourage that. Oh my gosh, encourage people to come up with different models of the universe. Blasphemy. Anyways, if you do want to nominate somebody, send me an email, david@naturalphilosophy.org, and I'll be happy to entertain that with our members, our directorates who sort of have a say in that. Tell them, this person's going to get it, okay? And they say, oh, no, I'm kidding. That's totally not true. Also, Greg Volk, I have him involved there too. So anyways, also... that's the great. This is what we're going to do. Ethers will present why their model is a good one. The other side will present why Ether is not a good model. That'll probably be me, because since there's very few of us. Ethers will rebut the objections, and the non-etherists will respond to those rebuttals. And of course, then the audience will chime in. So that's the idea of that. And the Lifetime Achievement Awards, there are very many deserving candidates. We wanted to dedicate an entire show to that candidate. They do get a certificate for that, which they can frame. We don't send the frame, because a lot of those times they're all around the world. People can frame them themselves, but it's a very nice, very, very nice certificate. Again, frameable. And we're going to dedicate an entire show to them. Of course, the nominations are welcome. We're also looking for hosts and guest hosts. If you are a person and you want to just maybe host it once on some topic, or you have a person you even want to talk with and you really like, and I'm thinking about doing that. Jeff Yee pointed out somebody he really likes, so I'm going to hit him up. And Jeff Yee is a really great guy. I love his work. Jeff Yee is a star in the area of critical thinking. If you haven't checked out his work, go to energywavetheory.com or something like that. Just check out Jeff Yee. He's also on our beyondmainstream.org. Really great guy. Maybe he could do that. I'm going to try to get other people than myself. That way, the people who come in, I have a few haters out there, but certainly it would be good to have different people also hosting this. So if you do want to do that, contact me, or if you have suggestions, that would be great. Today, we're going to be talking about evolving perspectives on the history of science, and this is part 3 of 3 parts on time in physics by Nick Percival. Probably, in my opinion, the premier human being on the planet who knows more about and who's thought more about time and relativity and all that than anybody. I would really, I would be very surprised as someone who spent so much time. And of course, being a critical thinker, that's the whole thing. I mean, you can think about it in mainstream, but being a critical thinker about this. And he says this is a surprise ending. So we're going to be, he's going to be giving a presentation today. If you don't know about Nick, he is an American scientist, entrepreneur, who is best known for his work criticizing, explaining Einstein's special theory of relativity's treatment of time. Nick graduated from Harvard in 1964 with a degree in physics. He spent, there's another thing, right? Oh, the people who work outside, they're a janitor or a surfer, and they just came up with they don't care about, nope. Well, we actually have people graduating from very prestigious colleges in the area of physics. So there you go. Spent more than 50 years focusing on the twin paradox for those. From those studies, has come to know the many problems of special relativity. As an entrepreneur, Nick started several companies in the late 1990s and co-founded TeacherWeb, providing teachers and education with an easy way to communicate and update, way ahead of his time. Of course, that's usually the case. And I believe I have a way to get to his. Oh, here we go. And he does have a YouTube channel, and I do have a way to get that right there. If you go to nick.naturalphilosophy.org, you're going to go to his YouTube channel. Please subscribe to him. Support by subscribing to his channel. He's got really great videos. In fact, his presentation today will be live on that. On his channel as well. And of course, he also has his own website, twinsparadox.net, which I'm going to have him on again. I'm going to have him on again because that is the super interesting story. I've heard it. I forgot most of it already. No, I didn't forget most of it. I remember it, most of it. But for those people, since we have such a new audience out there, I think it would be really great to to do that. So I'm going to leave that up, and I'm going to bring the man himself. Nick, how are you?
Pretty good. Sorry, I forgot to shave this morning.
Oh yeah, I know. It's a little embarrassing, but you look great actually. And tell us today. I mean, we've been talking about time in general. This is a three-part series. What are people going to maybe? Why don't you tell us the sequence of the three talks to put this into context for those who maybe this is their first video watching here.
Yes, part one relied heavily on Professor Lee Smolin's book called Time Reborn, where he talks about the history of how time has been treated in physics and came to the conclusion that uh, time, the essence of time, had been removed from physics, and there were some areas that it definitely required a redo because time and its essence needed to be put back into physics. And then I jumped forward to the present and looked at special relativity, which is what's accepted today in academia, and looked at how it treated time and found that there were a lot of paradoxes involved in how special relativity treated time. So now this one looks to the future and tries to find a way to put time back into physics. And the great surprise ending and irony is you really need to remove the old idea about time and replace it with something that's observer independent, operationally defined, and just inherently a terrific physics construct.
Right, right. I know a little bit about what you're going to be talking about, and I quite agree with it. It's funny because my mentor, Dr. Ricardo Carrizani, super brilliant guy, really brilliant man, was always would say, we need to really figure out what time really is, and that's going to be a very important thing. And I think, I think the problem with the time is that how can you don't even sort of know where to start. And I think the only way you can really have a grasp on it is to sort of do what you've done, which is to think about it for so many decades and look at so many things. It's not an easy conclusion to come to. So I'm going to bring up your video. We're going to start it off.
One
And
one quick thing
yes,
is that to give
yes.
me a little credibility, someone may start and look out the window and say, I see time passing right before my eyes. I'm just going to dismiss this. Well, I wrote an email to a group of CNPS people, and I've had three people, to my surprise, write back and say they've come to the same conclusion as well. So you've very well respected people.
No, absolutely, absolutely. There's no, I mean, to me, I'm putting it out here. In my opinion, you are the one of the foremost, if not the foremost person in time on planet Earth. I know Dr. Glenn Borker talks about time, but has not gotten into it the way you have. This is absolutely for those who love physics and the concept of time. This is the best out there. So let's get this started here. Again, you can go to nick.naturalphilosophy.org if you want to check out all of his videos. But right now, we're going to start this presentation off, and let's see what we got here. Okay, here we go. Okay, I got it off the, of course. Here we go. That's why we have to always do this live. Let's try this again, make sure everybody's hearing it. Oops, it's not hearing it, huh? Okay, that's weird. We tested this, didn't we? Okay, I'm going to bring you down here, and let's get this here. See if we can do this again now. Coming, so let me remove this. I'm going to remove it and start from the studio. There we go. We're going to we tested this earlier, so here we go.
Hi. Thanks very much for taking the time to come and listen to this talk. It's greatly appreciated. First, let me talk about the mode of listening to this talk, because I've learned through experiencing that if one is listening to a new idea, or indeed any idea that runs counter to your currently held strong belief system, it's very challenging. And for new ideas, don't mentally rebut every point and every sentence as it comes out of the presenter's mouth. I've had 50 years of experience debating the special relativity theory. The only answer I ever got was, you don't understand special relativity. So even if I, or others, many others, gave very clear, simple, logic arguments showing that special relativity leads to a flaw, or a second interpretation of special relativity doesn't match the empirical data, that's received by the special relativist as, oh, your conclusion is that special relativity is wrong, but my belief system is that special relativity is right, so there must be something wrong with your logic. QED. Let's avoid that. And instead, I ask that you suspend critical analysis until you fully understand the whole thesis. Okay, short intro to the presentation. It's mostly a shortened version of 2 videos at the end of my Nick of Time 34-part series on time that I think the last video was made in like 2018, and then I've gotten distracted, but I hope to get back to that topic. I've got some new ideas. And Professor Percival says, somewhat tongue-in-cheek, you can get a CNPS University course credit for this presentation, but to get a PhD, you need to see the whole series. And after listening, we can have a friendly debate. Hello, this is Nick of Time. Welcome to this, our 33rd video in our series on time in physics. As you can see, it's entitled A Surprise Ending, which we normally think of as something that the author puts at the end of a book or story to surprise his readers. Well, in this case, the surprise was on the author, namely me, as I came to a new view about time at the end of this series. So this video and the next video will talk about how time does not have physical reality. It's a construct that we invent in our minds, but there's no correspondence to time itself in physical reality. 50 plus years ago, I started on a physics path. I went to special relativity to look to see how it handled time, but it just seemed to have circular logic and be a dead end. So I continued on my way. I came to general relativity, and interestingly enough, it seemed to have a completely different model of time. I continued on and worked with Ron Hatch, expert in GPS, and looked at all of the GPS empirical data on proper time. And it seemed to me that ultimately the path inexorably led to the view of time that I'm talking about today. And we'll now take a look at the last 2 years where I was doing a series of 30 plus videos on time in physics.
Now, when I started the series almost 2 years ago, in that first talk I said, I had a couple quotes here, I said that time, we're going to look at time not from a philosophical point of view, but from a pure physics point of view. And to do that, we need to build time on a rigorous construct. And that rigorous construct was proper time, which was a true physics construct with an operational definition, and it's observer independent. So 2 years later, I really hadn't been thinking about this philosopher's idea of time in quotes. I had just set it aside as being too vague and didn't seem like it was specific enough that one could build physics on it. But I've sort of taken another step since then, and I wasn't, through that 2 years, I wasn't thinking about the philosopher's idea of time, but maybe my subconscious was, because I came to the conclusion that, hey, proper time is all you need. The philosopher's idea of time seemed superfluous. And the idea didn't seem to have any existence in reality, and further, it was kind of misleading as to what the reality of time was. And actually, without thinking about time, a pure physics view of time occurred to me spontaneously very recently. So let's look at proper time again. Proper time is operationally defined as the time accumulated on a clock between two events where the clock is present. So there's no ambiguity. It's crystal clear exactly what you mean by proper time, and proper time is used throughout all of physics. A clock is driven by a process. So when you think about it, the units of proper time are really units of a process. Basic clock shows hours and seconds, but that's sort of a translation into a common language of time, but the clock is just representing the number of cycles or vibrations of a physical process. So proper time is very physical, it's absolute, and observer independent. Very well defined construct. Now we're going to talk a little bit about philosopher's time. I was most of the way through my 32 first talks when I got a call from a philosopher who was writing about time. And a physicist who knew him told him, gee, you better give Nick a call if you want to understand the physics of time. So we had a series of communications, and he pointed me to all of his favorite philosophers and their key writings, and I read them, and they seemed just like a bunch of words to me. That didn't translate to physics, and in fact didn't really translate to reality. So I just sort of put that aside. But to try and give you an idea of philosopher time, it says time like space has its own existence beyond clock time. For some, I got the feeling that they're kind of thinking that there's some universal clock outside the universe, and 10 ticks on the universal clock is the real measure of time, and it may equate to 3 ticks on a physical clock on Earth and some other number of ticks on a physical clock on Jupiter or whatever. But I came to the conclusion that philosopher's time, and when I write time with a capital T in quotes, that's my shorthand for philosopher's time. Save a little space in doing the presentation. So philosopher's time, to me, is an academic abstraction of the concept of time, and as such is a bit dangerous if you have it influence your thinking on physics. So I came to think of philosophical time as really being psychological time. Philosophical time it seems to represent time that we move through, or that flows along past us, or that we are swept along by a flow of time. But I think that's a purely psychological model that we create as infants, and it's a very natural model. When we look around and we see all these things that move and whatnot, that it's not space, it's movement, it's time. So we continue to experience that way, and our language is built on, I think, the philosopher's construct of time, and probably one sentence in 10 will talk about time, and not necessarily in the context of proper time. But I contend that time is not part of physical reality, philosopher's time. But because we've experienced it all our lives as being that way, it's going to be tough to adjust our thinking to a new perspective on what is time. Let me expand on that. I claim it's not like a river that sweeps us along or flows by us, and the past, present, future do not all exist simultaneously. The past no longer exists. At best, it's just a partial history of processes that exist. We have history books that tell a story about what happened, but many of them slanted this way or that have nothing to do with what actually happened. In the Grand Canyon, there's lots of sediments that give kind of a partial history of the epics of geology, but that partial history is open to interpretation and misinterpretation, and it certainly is not the whole thing, and it's not, you can't step into the past by looking at it. Similarly, the future does not yet exist, so there's no sense of things flowing by or us flowing into the future. Okay, the psychological construct of time, I contend, adds nothing to our understanding of physical reality, which is what these talks are focusing on. Further, the psychological construct of time, philosopher's time, is misleading and quite dangerous.
Hence, based on what we just discussed about the past and the future not coexisting with the present, time should not even be represented by a line going from past to present to future. At best, time is a point representing the current moment, and a point has 0 dimensions. Further, I hope we'll see later on that in reality, time does not exist at all, except in our minds. And hence, it's not even a point.
The philosopher's time, I'm saying, should be replaced by looking at energy and processes. Rate should not be expressed in terms of time, but process rates, which are expressions of motion and cycles and vibrations, which in turn are byproducts of energy. So I'm thinking of physical time as not being an entity unto itself, but a byproduct of energy. When I say that it's a property of processes, it's sort of like color. Color doesn't really exist as a physical entity. Matter emits a vibration of a particular frequency that's interpreted by our brains as being a color. And I'm saying time is somewhat similar to that. It can be manifested by vibrations which we interpret as time. So it has a physical reality, but it's not an entity unto itself. It's sort of a byproduct, property of other physical entities. For example, 1 second, here's our unit of time, but what is it? It's really defined in terms of a specific process, the number of vibrations of a specific process. Now, as I mentioned before, not only is the construct of philosopher's time embedded in our brains and the way we think since infancy, but it's also totally embedded in our language, and I don't expect our language to change to be consistent with what I'm talking about here. For instance, we used to say, "Hey, honey, wait 1 second, I'll be with you." I don't expect people to say, "Hey, honey, just wait 9,192,631,770 cycles of the unperturbed ground state hyperfine transition frequency of cesium-133. For one thing, I think that takes about 30 seconds to say, and the other thing, it's kind of difficult to picture how long a delay it's going to be. Okay, let's expand on that about time expressed as processes. Actually, since ancient time, there's no way of expressing pure time. We always express things in terms of processes. Like the year, the month, the day, the hour are defined in terms, respectively, of the Earth's solar orbit, lunar orbit, the Earth's revolution around its axis, and for the hour, a fraction thereof. So, in a way, we've always thought of time as processes. It's just that we've abstracted it, and in our language, the term second, hour, day don't necessarily conjure up the process that gave rise to that particular word. Again, I contend time is not a separate entity. Physical time is a property of motion and physical processes. It's a byproduct of physical causes and physical effects. One example of that is physical energy causes physical motion. That's an effect. And when we see something moving, that conjures up the idea of time passing.
Since the idea of time as something real, that's part of physical reality, that idea is so strongly held, let's try a little exercise. Let's think of a 100% static universe. Let's say the universe is made up of inert blocks, totally static, no atoms or any movement, internal movement, no gravitational attraction between the blocks. So one would have space but no sense of time. Now, fill that universe with energy, which then causes motion with those inert blocks and change, then time seems to be added. We think we're seeing time unfolding, but what we're actually seeing is energy, and energy causing change within 3D space. So I had proper time as the replacement for psychological time, and as I said, proper time is based on clock time that's displayed to us in minutes, seconds, hours. But the physical processes that drive the readings that are displayed on a clock face or other clock display, those physical processes are what drive that reading. They're the primary mechanism. That's where the real physics is going on. And then the real physics of processes gets translated into the language of human psychological time. And the process length that underlies proper time, that represents the fundamental reality behind or underneath human time. So we're getting displayed human time, but that's because there's a translation of counting up, keeping track of processes and process length, translating it into human terms. What's really happening at the physical level is processes, and all of their cycles or all of their revolutions or whatever is the natural way to keep track of process. So time is a generalization. The concept of time was built on many different stable cyclic processes. We have the year based on the Earth's orbit, the day, lunar cycles, And today the second is defined in terms of a specific atomic process, the number of cycles that accumulate. All those different processes and their durations have been generalized into a concept of time. But that concept only exists in our head. It's not a single time property that's moving or flowing or whatever. The problem is that the connection between time that we think about and the processes that gave rise to the language of time and the concept of time are at best secondary in our mind, and in many cases the connection between the processes that gave rise to the definition of the language of time has been totally forgotten, or we just ignore them. We think just in terms of time. And that gives rise to some erroneous concepts, such as the intuitive concept that time is flowing by us from the future to the current moment and into the past. Concepts like duration. Hello? Oh, you loved part one. Great. Thank you. I'm in the middle of doing part two. Okay, thanks again. Yes, duration in the model of psychological time is an important property of what we think of in terms of time. And time has many other properties that we associate with time. Now, duration in this model that's just in our head and not directly describing physical reality, duration is described in and measured in the language of psychological time, namely seconds, minutes, hours, which incidentally all come, their definitions all come from physical processes, a variety of different physical processes. But this tends to be forgotten when we're just talking about duration in terms of psychological time. However, if we build a model that's directly referencing what's happening physically, then when we look at processes are the foundation of that model. And each process will have duration as a property of that process. And duration in that physical model will be measured in terms of the inherent characteristics or properties of that process. So, duration in the physical model is measured in terms of cycles or revolutions or steps in the process. So duration and all these other properties of time have their counterpoint in properties of processes, all except one, namely the psychological time abstract model that doesn't correlate to physical reality has time being a dimension unto itself, whereas In the direct physical model, where processes are the fundamental building blocks, the foundation, we don't have each process have its own dimension. That would be totally superfluous. Okay, let's look at an example. In psychological time, we might say something takes so many seconds. That's the language of psychological time. And it's a very useful language, and I'm not saying we need to get rid of psychological time. It has its place, like an ordinary casual conversation, or even it can make things simpler in even parts of physics, as long as we understand we don't need to add another dimension when building a physics model. Okay, but in contrast to the 1 second, we would say that the duration of the cesium atom vibration in its ground state hyperfine transition is cycles. So duration can be talked about as 1 second, but that's in the language of psychological time, whereas duration in process time, or process length, would be 9,192,631,770 cycles. And the same general analysis applies for all of the properties that we think of as properties of time, except having its own dimension. Let's look at the construct of rate. Most people tend to think of rate inherently implying time. If you look at what's actually happening physically, you'll see that rate compares a specific amount of one process length to another process length in standard terms. So let's analyze one example, miles per hour. 60 miles per hour compares the process length of the process of a car having traveled 60 miles to 1/24th of the process of one Earth rotation, alias 1 hour. Now we can look at it from another angle. Let's say that the wheels of the car have to turn 100 times to go 1 mile. So to go 60 miles, they'd have to turn 6,000 times. So if we measure the process not in terms of miles traveled, but in terms of the natural units, or a more natural unit of that process, namely number of times a wheel turns, we'd have 6,000 revolutions of the car's wheels occurring in 1/24th of the process of one Earth rotation. That equates to 60 miles per hour. Let's look at a very different process. Let's look at the rate of an old 78 record. So that's 78 revolutions of the record per minute. And since a minute is 1/60th of an hour, that means there are 78 revolutions of the record for every 1,440th revolution of the Earth. So, again, rate just compares one process length to another process length, which is usually cited in some standard term. Let's look at the construct of past, present, future. Again, most people automatically think of that as an inherent structure of time. Well, let's look under the generalization of the concept of time to see what's actually happening physically. And the only thing that's happening physically, every process has a sequence of states. So that's the model that really exists, a sequence of process states. The state that we see, the active state, corresponds to our mental model of time as the present. Active state corresponds to the present time. Similarly, prior states in a process's sequence corresponds to the past. The next states in the sequence correspond to the future. So, if we wanted, we could change the terminology from the past, present, future of time to moving from the prior states in the sequence to the active state to the next states in the sequence. However, what we do is we generalize all these very different process sequences as time unfolding, where it's really each process is unfolding in a sequence of states driven by energy. That's what physically exists, and only that. There is no evidence that there's some great machine that drives the entire universe forward second by second. No great energy force that's driving the universe forward second by second. Okay. I propose something. It needs to be testable to be good physics. Well, we can see if, let's say, special relativity's time dilation is a function of time, or is it a function of processes? What's changing? Is time expanding or processes slowing down? All right, the test would be, take a set of clocks. And we're all using different physical processes to measure our psychological time, and change their speed and or gravitational potential. If it's time that exists, and it's time that's changing with time dilation, then all clocks should change in unison. However, we know the answer already, namely the amount of change, amount of slowing or whatever, and even the direction of change, whether something slows or speeds up, depends on the process. And I'll give one example here. If we take an atomic clock out in space, and we take, let's say, a hourglass, where you have sand running through the hourglass. We know from empirical evidence that as the gravitational potential decreases, as we move these two clocks to the surface of the Earth, the atomic clock will slow as a function of the gravitational potential decreasing. But The hourglass clock will speed up, and time will accumulate much more rapidly on that as we come closer to the Earth. That's because these clocks are not really measuring time, but they're measuring process rates, which are measured in terms of a process's cycles or a process's revolutions or whatever. So we really already know, if we think about it long enough, that time as a separate physical entity doesn't exist. And there's no such thing as time dilation. What we have are processes are affected by a number of things, such as their absolute velocity or their absolute gravitational potential. And also, we know that their GPS knows that they're affected by air pressure and temperature. So there's already some empirical evidence that the focus, if you want to talk about what's happening physically, the focus should be on the processes and not on some abstract concept like psychological time. Since many of us inside the critical thinking community do not have access to multi-billion-dollar particle accelerators staffed by 1,000 or satellites launched by NASA, we need to think in terms of low-cost experiments. Hence, I took 2 equally ripe bananas and put one in the freezer and one just outside the freezer. After 2 months, I examined the empirical results. I will leave it up to the viewer to interpret those results, namely that the banana inside the freezer had a slower decay rate than the one outside the freezer. So, viewer, do you contend that the slower decay rate in the freezer was due to 1, time going slower inside the freezer, or 2, the cold inside the freezer slowed the decay rate? If you choose to, I think you need to accept the corollary that psychological time is superfluous when looking at the physics of what's actually happening, and that one needs to focus on processes and their properties and the attendant causes, the physical causes that drive those processes, including process rates.
Why does trying to think about the physical reality of time matter? Well, I contend we need an accurate physical model. Otherwise, we're likely to go astray, even if we come up with the right numerical answers for certain physical effects. If we don't have an accurate physical model in mind, then that's certainly going to inhibit progress. And let me give an example. I think that special relativity's model of 4-dimensional space-time, with space and time morphing into each other, that's an example where the concept of philosophers' time as a physical dimension was very misleading and made it easier to go down the wrong path. There is an example of an academic abstraction that has no basis in reality, facilitating going down the wrong path in physics.
So, let me try and summarize. Physics, and especially relativity, incorporated psychological time into its models, which was fatally misleading. It had some other problems as well. So, if we look at it, we see that underneath the human concept of psychological time is proper time. Because proper time, while it's displayed in the language of human psychological time, it's measured as process length. And it's a very physical definition. And it really is based on what's happening physically. So proper time is an improvement over using a generalized concept of time, and even better, if you're thinking at the theoretical level and building a model, is to use process length, because that is what determines our measure of time. And I contend that process length view is all there is physically, and all that's needed in physics. I've gone from nick of time to nick of no time, and here's my new icon. Hi.
I'm on mute. Sorry that keep it on mute so when I'm typing. But I've got a lot of comments in the from people watching. But actually, that's quite amazing because we have this problem with the word time where it means so many different things because it's a very important concept that is things are happening really, processes are happening in the universe, and we found this necessity we've had to have with time. My first question to you is, being you're saying that time is really the process length, right? If there's a process going on, and there's a length of time for that. Where, because you've thought about it more than myself. One of my areas is linguistics. I love language and the meaning. Why do you think people came up with the word time?
Well, when the baby is learning about the universe, he tries to make sense of it all. And the physical reality is that every single thing that's happening has its own process behind it. And those processes have different intrinsic inherent properties. Some are vibrating, some are revolving, some are moving straight ahead or up and down. So it's a wonderful simplification to get used to thinking of things that are well defined, like an hour. The child gets used to how long 1 hour is, as opposed to having to memorize that process A has 93 revolutions and process B has 2 trillion vibrations to describe the same amount of duration. It's a wonderful simplification, and I'm going to continue to use it in common day communication. But let me just add one point, and that is there isn't a separate thing called time, and that we move through time or time flows past us, what really happens is that energy or something else is driving these processes totally within three-dimensional space. If one remembers anything, remember that phrase.
So that's another problem, obviously, and I'll put up a comment here. I can star comments now, which is a really nice feature here, and they're talking about time. Einstein made it arguably worse. People actually think that time exists. Um, how do you interpret it? Because when I think, we have three dimensions, and those dimensions can uniquely describe a point in what we call space. And then, of course, people mathematically said, well, you can be there, but there's motion, and there are things that, like, I'm here in space at this time, and then I'm not, I'm over here in space at that time. And somehow that got convoluted into another dimension,
Yes.
which sort of doesn't make sense because if you even look at the physical picture of what the three dimension is, you have X, Y, and Z coordinates. Where's the time one? You can't, it says, where do you see, how do you think that came about?
Well, I'll just go back to what I said previously. It's a wonderful simplification that makes life easier to understand from a practical human point of view. But when talking about having a model of what's going on physically, you need to get rid of that human generalization and look beneath it and see what's actually happening physically.
Right. And so this whole thing of time flowing, it's really more of, I think, people's recognition that is what you're saying. It's a process, it's a sequence of things, and you're just saying, yeah, to have time you have to have these sequence of things, passing by. Excuse me. And that itself, I think it's tough because time is so important. I mean, we have to realize too, even if you look at ancient civilizations, Stonehenge, you look at the Mayans, it was huge. I mean, literally huge at the Stonehenge, what time was. I mean, those things were obviously lined up to sort of tell time at sort of an annual scale, but it seemed to be very, very important but if you look at it, it's more the processes that these people observe, perhaps the
Exactly. Yeah.
seasons. So what you're talking about, these processes, that's really what they're doing, and they're helping use the other cycles that are going on to help them with things they know is like, well, when do we plant something
Yeah.
so that it's the right time?
Hmm.
The right time. So,
Yeah. Even in my presentation, I talk about time.
right, right. Okay, I'm going to put some other comments that I've starred here. Again, if you want to come on, you can go to to naturalphilosophy.org. You can come in the green room and talk live with Nick here. But I've starred some of these. It says, this person said, T, time, and relativity tends to usually be related to dilation of time, which has nothing to do with time we normally think of. Is that sort of a characteristic of trying to untie the Gordian knot of relativity and time?
Well, there are two parts to that. Yes, time in relativity is often related to dilation of time, which we talked about. That's very confusing because time dilation is dependent on absolute, well, in special relativity, it's dependent on relative time between two observers. When in physics, GPS shows us it's really dependent on velocity, absolute velocity, with respect to the ECI frame, the Earth-centered inertial frame, at least in the locale of the Earth.
Right.
So the fact thinking of time having its own dimension really was a fatal error for special relativity.
Yeah.
The other major error was making a physics theory based on observer-dependent perspectives that all
Right.
disagree with each other. Those two things.
Right, right. I mean, it got doubly confused because of that, where you're now looking not at actually the event, but the observing of the event from different points of view. This is one that is you can understand. I can understand quite a lot why people get mixed up with it. I know Kevin Kahn here saying you're confused. Time is a coordinate. Here's what I would say. Time has been written in our symbolic math system as a sequence of x, y, z, x comma, y comma, z comma, and t comma. It is a system of how do you say a symbolic system we use to do calculations. Now, to say that mathematics and mathematical systems, that when you then put time t into a parentheses with commas, that in the physical world translates into that thing being the same as the other things, is kind of absurd in some sense. It's easy to see where people think this is just. It seems to be this is the real problem of mathematics, where people don't understand that mathematics is a symbolic system where we try to do calculations on processes, right? There, where we want to predict what's happening. But just because we come up with a symbolic system where we can put in a function and put x, y, z, and t into a function, does that not necessarily then qualify that to say, oh, it's a dimension? I mean, we can call it that in a mathematical system, but the physicality, it's you people really have this problem between math and the physicality. Is that how you would interpret this, or what would be your take?
I think that's a very good explanation, but there's another way of looking at it. When I entered college, my only assumption about physics was that my physics professors knew everything, and that everything they said was to be believed. And it took quite some time before they said something, and this was regarding special relativity and the twin paradox, which obviously didn't make sense. So that started my journey as becoming a critical thinker and being able to independently analyze what was being said. Now, I've seen a number of comments by Kev Kahn, and it's pretty obvious that he's studied relativity and believes it to be true. And in that context of his belief system, what he says is quite accurate. But, I think further on, he's going to, if he continues to listen to these programs, he will, by osmosis, begin to see that there are some problems. And that's just the road that people travel.
Yeah, it is. And again, because language is so, I mean, this is what we call science poetry, right? We it's really so easy to take a word and you can do whatever you want. I mean, it's an open universe. We have you can use whatever word in the way you want it. And that because of that, we really have it's really takes some time for us to understand that the mathematical system, which is this kind, which Kevin says here, we use math because it works. Absolutely. It's absolutely necessary, even though the real number system's got a lot of problems.
Yes, as Professor Smolin himself said, you need math, but you also need to have that math grounded in a physical model that makes sense and coincides with reality. For any bit of empirical data, you can come up with 10 conflicting math systems that don't make sense. What you need to do is make the next step and see if those models make sense physically and are consistent physically and consistent with the empirical data.
Yeah, yeah. Again, this is just a funny thing. It says Nick said it took some time to become a critical thinker, so
Yeah,
really a
do it all
process.
the time.
It's a process.
I'm not gonna I'm not
I
gonna
thought that was
say it
funny.
takes 9 billion
Right. And well,
cycles.
here's the other thing. If you remember, Kurtzendall's, he has a new math system, because here it's really interesting. Kirkendall, I think his name is.
Yes.
He's in our book. I reason I put him in the book is because he recognizes one very important thing in our mathematical system. Right, it is useful, as Kevin says. That's totally true, but we have negative numbers in our real math system. There's no such thing as negative in the universe. There isn't. You can't point to one place in the universe where you can say, yeah, the universe has, that's what negative is. It's not, for instance, when we do sine waves, right? We do sine waves, it's really, we graph them and they go positive and negative. But if you really look at the cycle, the physical cycle, let's just say it's an AC cycle of electricity, and you have electrons or whatever you have that you say electricity is moving back and forth. It's starting out with nothing, it moves up, it goes, yeah, it gets to a peak and then comes back down. It isn't moving in a negative direction. There is no, there's no such thing. Our mathematical system, even the real number system, negative numbers, the square root of negative numbers. The Kirkendall, what was he was trying to do, Kirkendall, I believe, is he was saying we can come up with a math system that is consistent with the physics of the real world.
Hmm.
And so what you do is you have a number, and that number is a direction. It's not a negative or positive. It's just, and it was quite interesting to see that. So, we do have Kevin says here, says, I never said relativity is true, only that has never been disproved. I don't believe anything. Well, the disproving part, talk to Dr. Cynthia Whitney, who got her PhD. Okay, this is what I'm going to say. Kevin, I'm going to say this to you, and this is some evidence against relativity. Dr. Cynthia Whitney, who got a PhD in special relativity from MIT, has had an assignment to apply her work to a ring gyroscope. That is what we call, commonly I think we call it the Sagnac effect, right? Where you have light going in a circle. And then what happened was when she applied it, it didn't work. It failed. She went to her professor at MIT in physics. She has a PhD in relativity, and her teacher said, yes, we know it doesn't work. So the question becomes not whether or not, if it's never been disproved, it's how many ways. In fact, I think it was either Dr. Glenn Borkert or someone else who said, and I think they're rightly so, or maybe it's somebody else, maybe Harry Ricker said it, but people who have looked at especially special relativity for so long, is that relativity is the most disputed theory on the planet. If you look at dissident work, almost every critical thinker I've really met who took the time to really study use their critical mind on special relativity especially, has very quickly come to the conclusion that it's paradoxical. So it is something in your, I think a related question to you would be, Nick, is what in your studies throughout these decades of time has shown you, or that you would say to Kevin, no, it doesn't work. It's been shown that its predictions aren't true. What would you say to a person like that with your experience?
Well, a couple of things. For the twin paradox, where we discussed one of a number of different models that underlie special relativity, which are contradictory one to the other, but which are all accepted by academia, and they trot out one to try and counteract one problem. And then if they need to counteract another, they'll trot out a contradictory model. For example, GPS is claimed to be developed on special relativity. However, Ron Hatch, who had more than 30 patents on GPS, one of the key designers, and probably knows the GPS data better than anyone in the world, says that the GPS data categorically disproves special relativity. And that is not just an experiment where the experimenter can, push it one way or the other. This is a system that has to work to very high precision,
Oh
and
yeah,
it disproves special relativity.
yeah.
And other consultants to GPS agree with Ron Hatch,
Yeah,
who unfortunately passed away last
yeah,
November.
yeah.
Yeah.
Well, we were lucky enough to honor him with a Lifetime Achievement Award for his work. It was interesting when he was in my film, and he was the first investor in the film. He said, my mom asked him in the film, if you want to see it, EinsteinWrong.com, go and you can see it online. But she asked, well, what happens when you wrote your paper on how GPS doesn't agree with relativity? In fact, it's got problems. And his answer was he was greeted with silence.
Yeah.
And it was funny though, but most people do say it. But I think the problem is they don't want to be the one that says the emperor has no clothes. They don't want to be that. They have their marketing for whatever they do. Ron Hatch had Navcom, which was purchased by John Deere tractors, and they don't want to have this controversy of John Deere tractors in their GPS says relativity's wrong. They're crazy and that kind of thing. So. Let's see. So let's see what he said. Stop going on about GPS. It's a trivial to debunk that story. Okay. Well,
Well,
I mean, this is again, if you really take the time to look at it, which here,
mm-hmm.
I think this is the problem. People on an emotional side will just come back at it.
Yeah.
You'd have to, I don't even know how a statement like that could even be backed up. I mean, you would really have to go to every debunking kind of argument and then go find that wrong. I just, I think at that point it mostly becomes emotional. So we have James Keene. I also know we have other people in the green room. If you want to have a question or say something or comment, just wave to me. I can bring it up. If you do want to, oh, I've got two people waving, so I'll take the first one who was here. That's, in fact, I'll go to this mode here. Hey, James Keene, how are you? Great to see you as
I am
always.
fine. Hi, Dave, and hi, Nick.
Hi,
Mike,
James.
hello. My great presentation, and thank you very, very much, sir. Question: if process length depends on variables like gravitational potential, is there a place for a universal clock time in a complete physical theory? That's my question, and now I'll be quiet and listen. Thank you.
Yeah, if one knows the physical effects on different processes, then it's easy to, it's theoretically possible to construct universal time based on process length. In fact, GPS is a model of doing that. They require absolute simultaneity to have the system work, and therefore they need to know the effect on the one type of clock they use, which are atomic clock. And it seems that atomic processes are slowed by absolute velocity with respect to the ECI frame in the vicinity of the Earth, and by differences in gravitational potential. Now, if they shifted to another type of clock, they'd have to find out empirically how those effects would affect those clocks, and they won't necessarily all be affected in exactly the same way. And so it will take physics knowledge of what's really happening physically in each process that's being used to create a universal system. And probably the easiest thing is to use one type of clock. Say like everyone uses this type of atomic clock, and then at least the physics problem is simplified a bit.
It's really becomes down to an engineering problem, really, right? I mean, engineers have to deal with the physical world,
Yeah.
and they're going to have to understand that you know. And I thought it was brilliant the idea that, oh, here's all the different clocks. You have the a hourglass, and you have the atomic clock, and they're all affected by gravitational fields. There's all kinds of other things that are going on. And if time were some kind of thing where it was, kind of universal, then these things would all slow down in, I guess, some same way. But it goes to, it's, I don't know, it's almost for me it's almost impossible to extract the idea, or for me to come up with now the idea that time is actually something, because I guess it's more of unraveling it in your mind. That is the psychological perception of what we call time. It's more of having to go from that, because that's what we're going to have as human beings. I don't think people naturally necessarily think right out of the gate that time, which is this flowing of sequences or things that are happening, that we see cycles, the earth, days, those kinds of things, that those things automatically as human beings would give us the concept of, oh yeah, there are processes and all that. So I think that's a hard thing for every human being to get from the point of, oh, time is a dimension and we have it mathematically and it's in the equation, or
Yeah.
to get to the point where we're really just thinking of the physical world. All right, we have Harry Ricker who is waving his hand, I know, and I'm going to bring him up here. Harry?
Hi, David. I want to ask Nick some questions, and maybe we can clarify a little bit about this discussion. As I understand it, Nick, I think your thesis is something like this. Time defined physically is what time is as you perceive it. Is that correct?
I didn't get your last sentence. The last part of your sentence was.
My point, I think what you're trying to say is I think your idea is to say that the way relativity or special relativity uses time isn't really the correct definition of time in physics. I think that's what you're trying to say. Is that
that's
correct?
part of it. That's part of it. But more than that, I'm saying that time is a human created concept that has no counterpart in physical reality. It comes from what really exists in physical reality are processes that are driven by energy or forces. And when humans see it or try to measure this construct they've come up with called time, what they always measure is one process or another, one stable rhythmic process, because that's all that exists.
Well, I understand that. Now, the point I'm really trying to tease out of you is, and this is my view of what you're saying, correct me if I'm wrong. I think what you're saying is that the problem with special relativity and physics is that special relativity combines philosophical time with physical time, and by doing that, they produce a contradiction.
Correct. They go off on a fantasy, and even though the math may have no mistakes in it, of course, you may disagree with that, Harry. It just, they went off on a fantasy that didn't tie to physical reality. That when explained, most people can see it because it leads to a very obvious uh, contradiction, as Henry Dingle pointed out. At least one interpretation of special relativity.
Well, uh, Herbert Dingle.
Yeah, Herbert Dingle. Yeah.
Herbert Dingle. Herbert Dingle in his book Science at the Crossroads is a must read for anybody who really wants to understand the critical thinkers' criticism of special relativity and general relativity, because general relativity is derived from special relativity. So your thesis is that instead of being a theory about physical time, special relativity and general relativity are theories about philosophical time. And my view on that would be, well, if you're talking about philosophical time, which is kind of an imaginary construct that doesn't really exist physically or have any real connection to physical processes, then yeah, you can construct a theory that says that time dilates and changes. Well, of course, special relativity and general relativity go beyond that. They say space can be changed because there's just, that's an imaginary concept or a philosophical concept, as you would say it, as well. So then by defining time and space in general relativity and special relativity as philosophical constructs, instead of being real physical constructs, we get that they change and time dilates, space contracts, they morph around and change because they're not really it's not really a theory about physics. It's a philosophical theory that uses philosophical ideas in place of physical ideas. And so it gets all messed up. Would that be what your thesis is? Does that sound what your
Yes,
thesis is?
I think you have stated it quite well. I'll just make one fine point. It doesn't really disagree with what you were saying, but special relativity's model differs from general relativity's model. They're two different models, and that's the reason why academia has never been able to fuse them together seamlessly. What happened, I think, when Einstein derived his basic general gravitational equations, there was nothing really wrong with that. But what happened then is they added a lot of the special relativity problems on top of that. And that's one reason why a clock time corresponds well to general relativity's prediction about clock time or atomic processes being a function of gravitational potential. So that very core of general relativity, don't quibble with, but what they did, expanding it, they brought over a lot of the problems of special relativity and went awry. And you've described those well for both special and general relativity. Yes.
Well, I'm done.
Thank you, Harry.
Okay. Thank you very much, Harry. Appreciate it. I always like Harry and all the other electrical engineers. They seem to have the feet on the ground more than anybody. We do have some other. Yeah,
David,
go ahead.
you mentioned engineering. That reminded me that back in the days when we were in the NPA, we used to have people come on who were actually doing things, and to have them do it correctly, they said, well, we don't use special relativity because then it doesn't work. We had quite a few of those presenters.
Yeah,
And in
wasn't there
addition, your film Einstein Wrong, we had the director, I guess, of the Stanford Linear Accelerator, and he
Yes.
says the first thing we have to do is unteach people about special relativity.
That is so amazing. I mean, that was amazing because when I went to do that interview, they discovered my film, what it was about, because that was the year 2005, which was the 100th anniversary of Einstein's quote unquote miracle year. And once they found that out, they said we couldn't go inside the accelerator because it wasn't in their interest of the community for us to be filming there. Yet this guy insisted he would still talk to me. I couldn't believe it because I actually have my mom in a Michael Moore format. That was my default. My default was if I wasn't going to get an interview with a real experimentalist, not a physicist, a theoretical physicist, that I would have her stand outside, which we did, and they watched us. Actually, they knew we were there. It was kind of that Michael Moore moment. But he went up on the hill. He talked with me right before lunch. Before we went up on this hill to film. We literally, my poor mom had to trudge up. My mom and my dad and this person, we trudged up this hill in Northern California to overlook the linear accelerator. And before that, I pre-interviewed these guys, and I said to them, I said, "So, what's it like to be a theoretical physicist?" And he turned to me and he said, "Don't you ever call me a theoretical physicist." He says, "I'm an experimentalist. I deal with reality." And so I could tell he was sort of in that. But the two things that he said, which was amazing, was one, he had to unteach special relativity to his grad students. And number two, that they didn't observe mass increase. Now, if you're going to observe mass increase anywhere on the planet, it's going to be in a particle accelerator. And so, but of course, as Karazani points out, in the end game, they use relativistic equations. What happens? You've got more energy predicted by relativity than
Right.
you have. And guess what they invented? The neutrino.
Neutrino.
Right, the neutrino. Of course, the dissonants love it because they think it's the hidden ether. We literally have several members of CMPS that try to use many of them actually use the neutrino in their models. One of them is gravitons, the other one's ether. So that's interesting. Here is somebody asking a question here. Nick, have you read The Golden Thread of Time? I don't even know.
Uh,
I don't,
and who is it? Is that?
Martin Hart. I don't know.
Oh,
But I don't know by Crichton.
but it says by Crichton. I don't know. Is that Michael Crichton who wrote
Yeah, I'm not
various?
sure if you have that information.
He
Then
was in my class at Harvard.
oh, he was.
Michael Crichton. Yeah.
Oh yeah. Okay. Wow. Okay. Cool.
No, I
And
haven't read the Golden Thread of Time. Is that fiction or nonfiction?
yeah, somebody maybe can put that down there. I'll take a look at it. So let's see what I've got. Some other comments here. Well, Nick, here's one. Well, Nick, that was what I always said. Why do people think they can measure time? You can't measure time
All
because
right.
you don't know how much time elapses through two process states. States the clock works with it. So I guess what he's talking about is you can't, you're not really measuring time, right?
Exactly.
I mean,
You
that's a
can't because it doesn't exist. You always, since time immemorial, measure processes and their inherent uh, measure, like a cycle or a rotation or something like that.
okay. Here's a qualification: Crichton M. Miller, and
Oh,
it is nonfiction. So,
I'll write that down. Yeah.
all right, stump the Nick, the expert in time here. Um, I don't know if I put this one up here. Not. I apologize. I need to unstar these stupid things that I already have done. I've gotten up there. But here's one also. I'll let you write that down. I may have put this up, but it's still worth saying again that don't confuse mathematical dimensions with physical dimensions.
Mm.
I think that something that
Yes.
you would agree
Very
with.
important. Very
Yes.
important.
And I think that's what's happening with, I know Kev Khan is here saying that it is a dimension. Again, it's in the system. I remember one of the people when our book that we
We stuck. I think David has become frozen in time. I'm not seeing any movement or hearing any words. Let's see. Well, I can try and look through comments. It depends on. I think I've answered James Keene's comment. So we may have to end early. If anyone in the green room wants to put something in the green room chat, I could address that, but something seems to have gone wrong in the control room. I'll mention one thing. In my banana test, by the way, that was a tongue-in-cheek for your
Yes,
humor.
absolutely.
Just
I'm
in
sorry,
case
I disappeared. I disappeared because my electricity's gone off twice, so I'm sorry
Oh my
about that.
goodness.
So, anyways, I know Franklin Hughes here. Hey, it's good to see you. Did you want to come up and make any comments? Or yes, he does. Franklin's never for a loss of words, which is actually a good thing.
Mhm.
Hey, Franklin, great to see you. How are you?
Hi, Franklin.
So another very stimulating discussion, and Nick, you have me that like the whole way, that time is a process, but I would still have to disagree that it's a quote unquote human construct. So I did a little googling on what human constructs would be. Say the one example I came up with is say love. So love is a human construct. If you were to say eliminate all the human beings, that construct would go away because it's obviously a human construct. But I would argue that if you were to do the same thing, that time would still exist as a physical thing in the universe. The Earth would still rotate around the sun, and things, our energy processes would continue without the need for humans to exist. So, how would you address that?
Okay. This is a paradigm change that I'm talking about. And those, if you present on it, most of the audience is not going to instantaneously change. This is going to be a long-term dialogue, because if there's anything that's firmly embedded in the human mind, it's the construct of time. It just, every day you've been alive, virtually you've been exposed to that, and it's an integral part of language. And I can't get through a presentation without myself talking about time. But what I'm saying about is, if you're building a physical model, I'm advocating that you realize that the construct we have is a generalization made up in the human mind that has no counterpart in physical reality. What only thing that exists in physical reality are processes and um, uh, processes unfold within three-dimensional space. There is no separate dimension for something called time. Time doesn't flow by us. We don't flow into time. Um, and if you're not won over by that, you're part of the 99%, and that's it. Um,
Yeah, I must say,
I don't think your analogy really with love really is germane to what I'm talking about here, because I'll continue to talk about time, and it's a very useful construct. I have no campaign to stop talking about time, or it greatly simplifies everything and is a valuable tool for communication, even within physics at time. But just your physical model, I contend, needs to take into account what's really happening physically. And I'm saying
well, I think
time.
there's some like confusing things. For example, the whole concept of say space time. right? Now, that is what I would consider a complete abuse of, any conception of time.
Right.
Put time on an equal footing to the dimensional dimensions. It just seems silly. And the concept that, the whole concept of space time. I mean, do you find that as much of a violation of common sense as I do?
Yes, I do. Yes, I do. Space morphing into time and time morphing into space. And
Somehow they're equivalent, right? It's like space becomes time.
Yes.
It's like, no, it doesn't.
Right.
It doesn't happen at all.
Right.
Yeah, I mean, when I was trying to say something before my electricity keeps going off. Hopefully, if you see me disappear, that's what's happening. But we had a first version of our book, and I was talking to a guy, and he's, well, what's it all about? And I was talking, you get into the whole, mainstream has a lot of problems, and of course, you got a person who spends their time watching Neil deGrasse Tyson, thinking they know about the universe, and so when we started, I said, well, what are some of the implications? Well, with gravity is this, and light's this, and he goes, no. General relativity is fine. They're made out of tensor equations. I know what they are. I know how they work. And I said, well, tensor equations are a system that describes no differently than Newton, which is another set of equations that describe bodies and how they would be, where they are in time and space and all that kind of stuff. And he goes, no, tensor. I said, well, space-time is not real. And he said, no, it's real. I said, well, so the tensor equations, those are real? He goes, yeah, that's a physical thing. I mean, here's a guy who's got probably at least a master's degree in computer science telling me, and I argued with him a little bit. I just couldn't get past that. He said that tensor equations were physical. I mean, because to him, the math is so beautiful and so descriptive that they fall in love with it, I guess. I don't know. But, people, the idea that math is real. The other person in my film, I think it was Peter Marquardt, talks about how relativity is really a theory of it's not a theory of events. It's not a theory that talks about what is happening, right? It's not like you're saying, the process of something. It's really the observation of those things, and that's where things go awry in my opinion, with relativity, is because you're talking about the physicality of observation of something, and then having the excuse my language, balls to say that light's going to be measured the same speed no matter what a reference for. I mean, it's really amazing how the symbolic world in our heads and the physicality is really hard to tease apart. And you're right, Nick.
There is physicality. There are certain things we can point to the world as being,
Right.
Actual physical things.
Right.
We can say here or not. Although Harry just came up with an interesting comment there that says that basically all scientific ideas are human constructs. I'm not sure that's exactly true, but certainly I would say the concept of space-time is a completely human construct, and I'm pretty sure its entire conception would disappear with the human race thinking about it. So that would be an example. But I would continue to argue that since physical processes do continue, there would continue to be recognized with or without us observing them, that time has more than that kind of human construct thing. There is a reality out there, and for certain theories, say like my own, which actually say that, like you're saying, proper time. I'm very attracted to proper time. I love everything you say about proper time, things that's measured by clocks and such like that. And but one of the concepts is that there is, say, a universal time that clicks independently. If you could find the ideal clock, it would not be affected by any external physical processes.
But I think that's an impossibility.
I think there is such a possibility of there being such an actual clock.
Okay, let me just contrast your idea and my idea. you're thinking about time because you're seeing things unfold in a sequence, and you think that requires time. The way I view it is instead, uh, energy or forces are causing change, and that's actually what you're seeing. But to make sense of these myriad of different processes, some of which are totally stable and some are unstable, so they go at different rates and are unpredictable. Um, but I see it as processes driven by some forces or energy unfolding within three-dimensional space. So that's I'll just leave that as the two contrasts, um, contrasting models
Well, I suppose
to
I
think about it.
did come up with one other interesting point, which
Mm,
is whether time is real or not, and
yeah.
that would be the concept of, say, time travel. Now, recently, I've ran into some videos about someone claiming they were able to travel time.
Yeah.
So, if that were possible, then I think that that would certainly put time on a very, very much more physical
Right,
reality.
right. So my
Now, I don't think
concept
that
would rule
happens,
out
but
time travel because what you'd have to do is run every single process backwards.
Right.
Um,
Right.
and, and I was trying to say that, the past, hey, that's gone. There's no evidence that the past still exists. We have evidence that helps us think about the past, but that's it.
well, it could
Yeah.
be. Well, there's the people who think that we all live in a, say, a computer or whatnot,
Yeah, yeah. Well,
and
that would change it.
the way you travel back in time is you say save game, right? So if you go
Yeah.
in the future and you get killed, you can travel back in a time when you were back alive, and you just restore the state of.
Yeah, if we were all just a holographic model in a computer, that would change things. Yes.
Yeah. It would.
Yeah,
It
I
would.
think like James Keenan. Actually, what he really wanted to say is that we are in the computer, and that there is actually the universal computer clock. I call it like God's clock, whatever, and that would actually be a physical thing, just like the clock in your laptop is a physical thing. Nothing can move faster than what is allowed by that clock, and
Yeah.
that would be an absolute thing.
Yeah.
Yeah. Okay. Well, thanks, Franklin. We're going to be wrapping it up here. Thanks for coming by and adding to the discussion. But certainly, this isn't the end of everything. And I think it's really more the beginning, right, Nick? I mean, the
Yeah.
beginning of trying to make this paradigm shift.
Yeah.
It's not easy. I mean, how would you, if you're talking to a person, just to wrap it up, how would you I know this is really going to be hard, but how would you in a short amount of time try to get people to say, okay, I know how we all think about time now, but how would you point a person in the direction, at least, to get to the point where even like Harry said, which I do agree, that all scientific ideas are human constructs. I agree with that 100%. But how do you get a person obviously taught to go from a shift of one of the most fundamental things that we have in our lives, which is processes, and we observe cycles and it's time, the length of these cycles and processes. How can you point a person who wants to be a critical thinker to get to a place, or at least start getting into the place where they can understand that, what you're saying, that really there are processes and time is just some kind of thing that we talk about that really is just that is a process that takes so much of, we say, time. How can we get to that place that you want people to be?
All right. Two things. One, um, realize that humans have never measured time directly. All the times that people think they've measured time, what they've actually measured is process length, and they would use some stable process so that it could be communicated to someone else how much duration has actually occurred. So that's one thing. Just think about we have never measured
Wow,
time.
that's very
We've
good.
never
Yeah.
observed time. We think we've observed time, but what we observe is change. What we observe is processes unfolding, but we have never observed time directly or measured it. The second thing is for physics people, I think if you look at my presentation, observe the path that I went through. I started off, I just wanted to get a good physics construct for basing a physics model on. So I wanted something that was not observer dependent, like special relativity. I wanted something based on physical reality. So I first went to proper time. And then I took another step and said, well, look, even under clock time, all clocks are driven by physical processes, and one translates X number of vibrations or X number of revolutions into our human language of time. So just think of that path of thinking that might possibly help.
Oops. I thought this was interesting because I do know about this linguistically. I forgot about this, but there's a Piraha tribe in Amazon that has no concept of time. And actually, the Hopi tribe is they're interesting language, but the closest thing that the Hopi language comes to in time are two words, one meaning sooner and the other one later. And if you look at that, what you're saying, it's very interesting because if you look at Hopi, they're talking about their processes, right? I mean, that's
Yes.
basically what they're
Yep.
saying.
Yep.
Either, something happened before. It's not time really. It's just like, that process is done, and another, later means a process to come. But very interesting. So I don't know. It says there's no past tense because everything exists for them in the present. This is the other one in Brazil. When it's no longer to be perceived, it ceases to, in all extents, to exist. That's true too. So very very interesting. Where we think that it's just completely normal, and that there are actually tribes out there that have language that they don't really have time as a real concept or even a word. So
Yeah, they exist in the physical world totally without any
right,
sophistication on top of it.
right. I mean, yeah. I mean, in fact, that one tribe in Brazil says if they don't see you anymore, you're not there.
Yeah.
So very interesting. Well, listen, Nick, one question before you go. Thank you so much, first of all, for this series. It's just absolutely amazing. The series is you can get this series on your YouTube channel. And again, I've made it so it's easy. I'll put this flashing at the bottom there. If you want to get to his YouTube channel easily without having to, even Google it, just go to nick.naturalphilosophy.org and you'll get that. You'll go right to his channel, which you'll be able to see the video that we saw today. And then my other question is to you.
By the way,
Yes.
right
Go
after
ahead.
the show, I'm going to make it public again. So it may be a
Okay.
slight delay before it's public.
Okay. No problem. But again, subscribe to his channel. You'll find that out. So go to his channel, click on the subscribe button, and when he does make a video and it's available, you will be notified. So that's really great. I get him even on my watch. It says, "Hey, Nick's got his new video out there." One question before you go is: would you be willing, and do you think that would be a topic we could talk for? About your project with the Relativity project, which I think is quite interesting. You've given talks or talked about that before, but we have a new audience. We've got new people who don't know anything about that amazing twin paradox project. You think that would be something you could present and talk about?
I definitely have all the material in hand.
Okay.
So it just depends on time,
Okay.
I am getting older.
Yes.
with
Okay.
time.
Yes, absolutely. But anyways, it's something to think about. But if you haven't gone to the, I think it's mostly documented, I think, on your
Mm.
twinparadox.net, right?
Yes.
Okay. So you can go to that as well. All right. Well, listen, thank you so much, Nick. It's greatly appreciated. Your work is absolutely fantastic. Really no words. People really have enjoyed this series. And I want to thank you from all of us to go through what you've gone through to come to the conclusions you have, because it's a long journey. And hopefully, your conclusions and your work will slowly be adopted by the critical thinking community and understood that, in fact, this is really what it is, what time is, and how we should really perceive it in the physical world in physics. So thank you so much.
I have to spend some time reading a new book that I just received. That it looks fascinating.
Yeah, well, only time will tell. So, all right. Thanks so much, Nick. I really do appreciate it.
Thank you.
Okay, thank you. So, folks, that's just fantastic. That's why remember to subscribe. If you're watching this right now, just hit the subscribe button, hit the like button. That's how we get more and more people knowing about what we're doing here. It's very important. That's the way the modern world works. So, if you're one of the oldsters, even like me, please do that. It just takes 1 second. Click on the like, thumbs up, and that will help out a lot. And remember, you can give us vital support by going to naturalphilosophy.org and becoming a member as little as $5 a month. We really don't want to. Right now, we're relying on memberships, but we still need donations to keep this going. I'd hate to see this go down because we can't keep up the minimal that we need to do to keep this organization going. So your support is very vital. So thank you so much for those who do support it, and please consider supporting that in the future. Stay critical, stay thinking. I'm David D. Hilster, your science therapist, trying to get you to the promised land of becoming a critical thinker. I'm not here to tell you what to think. I'm here to get you to keep yourself with an open mind, because that's the only way science goes forward, and that's where all the new stuff happens. Ciao for now.